Good afternoon, ma'am. Myself E.Ramadevi from 3rd Biochemistry. Today my seminar topic is factors affecting catalyzed reactions. Factors affecting catalyzed reactions. These are the 6 factors affecting the catalyzed reactions. First one is effect of substrate concentration. Second one, effect of inhibitors. Third one, effect of pH. Fourth one, effect of temperature. Fifth one, effect of pressure. Sixth one, effect of water. Enzymes in food can be detected only indirectly by measuring their catalytic activity and in this way differentiated from other enzymes. This is the rationale for acquiring knowledge needed to analyze the parameters which influence or determine the rate of an enzyme catalyzed reaction. The reaction rate is dependent on the concentrations of the components involved in the reaction. Here it means primarily the substrate and the enzyme. Also the reaction can be influenced by the presence of activators and inhibitors. Finally, the pH, the ionic strength of the reaction medium, the dielectric constant of the solvent and the temperature exert an effect. First one, effect of substrate concentration. Let us consider a single substrate concentration. Enzyme E reacts with substrate A to form an intermediary enzyme substrate complex. The complex then forms the product P and releases the free enzyme. In order to determine the catalytic activity of the enzyme, the decrease in substrate concentration or the increase in the product concentration as a function of time can be measured. Second one, effect of inhibitors. The catalytic activity of enzymes in addition to substrate concentration is affected by the type and concentration of inhibitors. Activators include metal ions and compounds which are active as prosthetic groups or which provide stabilization of the enzymes, conformation or of the enzyme substrate complex. Inhibitors are found among food constituents. Third one, effect of pH on enzyme activity. The reactions for the sensitivity of the enzyme to changes in their pH are sensitivity is associated with a change in protein structure leading to irreversible denaturation. The catalytic activity depends on the quantity of the electrostatic charges on the enzyme's active site generated by the prototropic groups in the enzyme. In addition, the ionization of dissociable substrates as affected by pH can be importance of the reaction rate. However, such effects should be determined separately. Fourth one, influence of the temperature optimum. Enzyme catalyzed reactions and the growth of the microorganisms show a so-called optimum temperature optimum, which is a temperature dependent maximum resulting from the overlapping of the counter effects with significantly different activation energies, increase in reaction or growth rate, increase in inactivation or killing rate. Fifth one, influence of pressure. High pressure change the tertiary structure and very high pressures disrupt the H bridges which stabilize the secondary structure. The hydration of the proteins is also changed by high pressure because water molecules are pressed into cavities which can exist in the hydrophobic interior of the proteins. In general, proteins are irreversibly denaturated at room temperature by the application of the pressures above 300 MPa, while lower pressures cause only reversible changes in the protein. Structure. Sixth one, influence of water. Enzymatic activity starts at water content of 0.2 gg protein, which means even before a mononuclear layer of the polar groups with water has been taken place. Increase in hydration resulting in mononuclear layer of the whole available enzyme surface at 0.4 grams protein raises the activity to a limited value reached at water content of the 0.9 protein. Here the diffusion of the substrate to the enzyme's active site seems to be completely guaranteed. For preservation of food, it is mandatory to inhibit enzymatic activity completely if the storage temperature is below the phase transmission temperature. Thank you, ma'am. Thank you, friends.